Three-dimensional space. Hello and welcome to our channel. Today we will be discussing the fascinating topic of three-dimensional space. Three-dimensional space, also known as 3D space, is a fundamental concept in mathematics, physics, engineering, and many other fields. It refers to a space that has length, width, and height, and is often represented using coordinates or geometric shapes. Understanding and visualizing 3D space is essential for creating accurate and effective designs, models, and simulations, as well as analyzing complex phenomena in science and technology. In this article, we will explore the properties, applications, challenges, and future directions of 3D space, as well as its relevance and importance in various domains. Introduction to three-dimensional space. What is three-dimensional space? Three-dimensional space refers to the physical world around us that has length, width, and height. It is the space in which we live, move, and experience the world. Three-dimensional space is also known as 3D space, and it is essential for understanding the physical properties of objects, their movements, and interactions. Why is three-dimensional space important? Three-dimensional space is crucial in various fields, such as architecture, engineering, physics, and computer graphics. It allows us to understand how objects relate to each other in space and how they move. For instance, a building's design involves creating a three-dimensional space that accommodates several structural elements, including walls, floors, and roofs. Understanding the properties of 3D space is also crucial in creating computer-generated graphics for movies, video games, and virtual reality environments. Understanding the dimensions of space. One-dimensional space. One-dimensional space refers to a straight line that has only length and no width or height. It is the simplest form of space and can be represented using a one-dimensional coordinate system. One-dimensional space is commonly used in mathematics, physics, and engineering when dealing with linear variables such as time, distance, and speed. Two-dimensional space. Two-dimensional space refers to a plane that has length and width, but no height. It is commonly represented using a two-dimensional coordinate system, such as the Cartesian plane. Two-dimensional space is used in various fields, including geometry, graphic design, and architecture. Three-dimensional space. Three-dimensional space refers to space that has length, width, and height. It is commonly represented using a three-dimensional coordinate system, such as the Cartesian coordinate system. Three-dimensional space is crucial in several fields, including physics, engineering, architecture, and computer graphics. Properties of three-dimensional space. Length, width, and height. The three primary properties of three-dimensional space are length, width, and height. Length refers to the distance between 2 points along the x-axis, width refers to the distance between 2 points along the y-axis, and height refers to the distance between 2 points along the z-axis. Volume and capacity. Volume and capacity are properties of three-dimensional space that describe the amount of space occupied by an object. Volume refers to the amount of space enclosed by an object, while capacity refers to the amount of material that an object can hold or contain. Surface area and curvature. Surface area is a property of three-dimensional space that describes the total area of an object's surface. Curvature is a measure of how much a curve deviates from a straight line. Understanding these properties is crucial in various fields, including manufacturing, architecture, and physics. How to visualize three-dimensional objects. Orthographic projections. Orthographic projections are two-dimensional representations of three-dimensional objects. They are commonly used in engineering and architecture to show different views of an object and its dimensions. Perspective and isometric drawings. Perspective and isometric drawings are techniques used in art and design to create the illusion of three-dimensional space on a two-dimensional surface. They rely on concepts such as vanishing points and foreshortening to create a sense of depth and spatial relationships. Computer-generated models. Computer-generated models are three-dimensional representations of objects that are created using specialized software. They are commonly used in architecture, engineering, and animation to create realistic models of structures and objects. These models allow designers and engineers to test their designs and make changes before building the actual object. Applications of three-dimensional space in science and technology. Three-dimensional space has numerous applications in various fields of science and technology. Here are some of the most significant applications of 3D space. Engineering and design. Engineering and design heavily rely on three-dimensional space. Engineers and designers use 3D models to create products, vehicles, and infrastructure-related projects. With 3D software, engineers can design, analyze and test mechanical structures, electrical circuits, and fluid systems. Therefore, 3D space plays a crucial role in engineering and design by providing an accurate and realistic perspective of the projects. Architecture and construction. Architects and construction workers use 3D space to plan and visualize buildings and other construction projects. Using 3D software, they can create detailed plans and blueprints, examine the building's structural integrity, and simulate various environmental factors. This helps to ensure that the building meets all safety regulations and provides a realistic representation of the final product. Medical imaging and diagnosis. Three-dimensional space plays a vital role in medical imaging and diagnosis. Medical professionals use 3D imaging techniques to create a detailed and accurate representation of human organs, tissues, and bones. This helps to identify and diagnose medical conditions such as tumors and fractures. 3D printing also provides a way to create prosthetic limbs, customized implants, and other medical devices. Challenges and limitations of three-dimensional space. While 3D space has many advantages, there are also some challenges and limitations to consider. Visualization and comprehension. Visualizing 3D space can be challenging, especially for those who are not familiar with the technology. Some people may find it difficult to comprehend 3D models and need special training to understand how they work. Measurement and analysis. Measuring and analyzing 3D models can be complicated, especially for complex objects. It requires specialized tools and software, and it can be time-consuming and resource-intensive. Technological and resource constraints. Creating and manipulating 3D models requires specialized software and hardware, which can be expensive. Additionally, not all devices or platforms support 3D space, which can limit its accessibility and use. Future innovations and advancements in three-dimensional space. Despite the challenges, there are still many exciting innovations and advancements being made in 3D space. Virtual and augmented reality. Virtual and augmented reality technologies are transforming the way we interact with 3D models. These technologies allow users to immerse themselves in 3D environments and interact with objects in real time, providing an even more realistic perspective. Advanced modeling and simulation. Advancements in modeling and simulation software are making it easier to create and manipulate 3D models. These tools are becoming more accessible to non-experts, opening up new possibilities for education and innovation. Interdisciplinary collaborations. Collaborations between experts in different fields are leading to new and innovative uses for 3D space. For example, collaborations between architects and engineers have led to designs for more sustainable buildings that utilize 3D modeling to optimize energy efficiency. Conclusion and implications of three-dimensional space. Three-dimensional space has become an increasingly valuable tool in many fields of science and technology. From engineering and design to medical imaging, 3D space helps professionals create accurate and realistic representations of objects and environments. While there are challenges to using 3D space, continued advancements and innovations will lead to even more exciting possibilities in the future. Understanding and leveraging 3D space will be critical for those looking to stay at the forefront of their respective fields. In conclusion, three-dimensional space is a multidimensional and dynamic concept that plays a critical role in our understanding and exploration of the physical and virtual worlds. The development of new technologies and methods for modeling, analyzing, and visualizing 3D space is constantly expanding our horizons and enabling us to solve increasingly complex problems. By grasping the fundamental principles and possibilities of 3D space, we can enhance our creativity, innovation, and problem-solving skills in a wide range of fields.